Hello everyone, I am Rashi Mahata from Mathematics and Computing Department. The topic of my presentation is file management in Android. Let us quickly brush through the basics of file management. A file is a collection of specific information stored in the memory of the computer system. File management is defined as the process of creating, organizing, modifying and deleting files in the computer system. File management in OS is based on the following concepts: file attributes, file access permissions, file operations, and file systems. Now talking about Android. Android is a mobile operating system designed primarily for touchscreen mobile devices. The foundation of Android platform is in the Linux kernel. Using a Linux kernel allows it to take advantage of the key security features and allows device manufacturers to develop hardware drivers for a well-known kernel. Android uses a file system that is similar to all the other disk-based file systems on other platforms. It supports multiple file systems such as RFS, ext4, WAFs, YAFs too. It depends on the manufacturer which one he wants to use. However, the most popular one is YAFs. So let us consider it for our further discussion on file management in Android. YAFs. So it was designed for use with Linux, but it is able to be ported to other operating systems as well. The basic unit of allocation is a chunk. Several chunks make up one block. A block is a unit of erasure. YAFs maintains a log structure. This means that all the updates to the file system are written sequentially. Instead of overwriting different data structures at different locations, the file system is a simple linear list of logs of the operations that take place on the file system. Clearly, such a structure is not very efficient, as one has to linearly go through all the logs every time. To avoid doing this over and over, it scans the events and constructs an in-memory object state for every object and a file tree structure to locate the files and the directories. File data still resides in the flash memory, but by having all the file and the directory information in the RAM, we can now quickly find out which blocks to read to get that data without having to scan the logs. These reconstructed data structures are stored in the flash memory when the file system is unmounted, so that the scan need not take place when it is mounted the next time. Now, as we all are aware, there are two types of storage in Android: external and internal. Every Android compatible device stores a shared external storage. This can be internal non-removable storage, also called as the primary external storage, or a removable storage media such as an SD card, also called the secondary external storage. By default, files stored to the internal storage are private to that application, and other applications, even the user, cannot access it. However, these privileges can be changed, and let's talk about that now. So, to manage the inter-application access, Android uses certain flags. Mode private, mode world readable, and mode world writable grant access, read and write permissions to other applications. Below are some of the helper classes which help us to write in the internal storage. Now let us talk about external storage. In order to read or write files on the external storage, the app must acquire the read external storage or write external storage system permissions. While handling files that are not intended for other apps to use, a private storage directory on the external storage must be used. Some of the helper classes in the context are given here. So the system consists of 6 main partitions in any Android devices. So to form the structure of the entire file storage, there might be other partitions, but it differs from model to model. They are boot, system, recovery, cache, and MISC. Let us talk about each of them briefly. This partition has all the data necessary for the device to boot. It includes the kernel and the RAM disk. This partition basically contains the entire operating system except the kernel and the RAM disk. Wiping this partition will remove Android from the device without rendering it unbootable. The recovery partition can be considered as an alternative boot partition that lets you boot the device into a recovery console for performing advanced recovery and maintenance operations on it. Also called the user data, the data partition contains the user's data. When you perform a wipe data or factory reset, it is actually this partition that you're wiping. This is a partition where Android stores frequently accessed files and stores them in the form of temporary and thumbnail files. This partition contains miscellaneous system settings in the form of on and off switches. This is not a partition on the internal memory, but it's rather on the SD card. In terms of usage, this is your storage space to store your media, documents, etc. It is like the equivalent of users folder on Windows or the home folder in the Linux operating system. This is not a standard operating system, but has become very popular in the custom ROM scene. It is basically an additional partition on your SD card that acts as the data partition, which can be used with certain ROMs. It is especially useful on devices with little internal memory allocated to the data partition. We've already talked about the directory structure in the introduction of YAFs. So let's talk a little more about it now. Each YAFs partition has a root directory. The YAFs directory structure is formed by a tree of objects of type YAFs object type directory. These objects have a doubly linked list for children and siblings so that all the siblings can be chained together in the directory. Each YAFs partition also have some special purpose fake directories which are not stored in the NAND but are instead created every time on mounting. First one is the lost and found. This is the place to store any lost file paths that cannot be placed in the normal directory tree. Unlinked and deleted. These are pseudo directories for placing the unlinked and the deleted objects. To understand the directory structure, let us consider the tree formed by this structure. Here we have the root directory with three children, all of them connected by the siblings doubly linked list. A has 3 children, C, D and E, again connected by the siblings linked list. D and E are data files as both of them are containing the data chunks. B and the lost and found lost and found directory are empty directories as they don't have any children. Okay, so now let us try to understand how files are actually stored in YAFs. As we already discussed earlier, instead of writing files in locations specific to those files, the file system data is written in the form of a sequential log. The entries in the log are all one chunk in size and can hold one of the two types of chunks, data chunk and object header. Right. So each chunk has tags associated with it which comprise of some important fields. Some of them are object ID, chunk ID, deletion marker, byte counter or the serial number. Here it is important to note that there are no file allocation tables or similar such structures in YAFs. This reduces the time of writing and erasing, which also improves the robustness. It thus conveniently avoids the problem of corruption of these tables, because when there are no tables, there is no scope of their corruption. Now when an object is changed or deleted, some chunks may be marked as deleted using the deletion marker. New information is placed in new chunks. When the number of chunks in a block that are marked as deleted become big enough, those blocks are erased and any non-deleted chunks are moved to another block. Thus all the areas in the memory is used. This kind of usage is referred to as the modified log structure. Since it deals with one block at a time, the amount of effort in one garbage collection cycle is constant. Thus it reduces the average stall time. YAFs also collects garbage differently depending upon if there's a lot of free space or if there's only little. It is called passive or aggressive garbage collection respectively. We will now discuss the last topic, which is how does YAFs ensure that the safety and the protection of files is confirmed. At regular points and on controlled shutdown, checkpoint blocks are written on the flash memory. They contain all the data to quickly rebuild the file system. Under usual circumstances, this checkpoint is used when a device is starting. If the checkpoint is determined to be corrupted or if the user has requested, then the file system is rebuilt using scanning. To do this, it makes a pre-scan to find the sequence number for all the blocks. Then it scans through the blocks backwards to build up the list of chunks that make up the objects. It speeds up this process by using block summaries. Now what is block summaries? It is the collection of all the tags in a block. YAFs is built with a fault tolerance as a guiding principle. So power loss is considered as a very normal event. There's a test harness which is used to subject YAFs to power failure and ensure it is working correctly even in the case of external data corruption. Here even extra wear leveling is unnecessary. Instead, it automatically wear levels because of the lock structure, because no part of the flash memory is used any more than the other. Now this brings us to the end of the presentation. Thank you so much for your kind attention.